Hello everyone and welcome to today's episode on this very channel. Today's lesson is just a continuation of what we did in our previous lesson. Remember that we are still on the same solution to first order PDE using the method of characteristic equation. And today we want to look at our third example. Remember that in our previous lesson we looked at only two examples. And in today's lesson we shall be looking at what? The third example. So this is our third example. We want to find a particular solution to the PDE y ux plus s squared uy is equal to 0 with the initial condition or subjected to the initial condition u of 0y is equal to y squared. Very, very easy and then simple. So as I said in our previous lesson, with the steps that I outlined on the board, the first one says that we should write the PDE given in a standard form, and as you can see it is already in a standard form. And then once we are done, we form the characteristic equation from this PDE given. But first we have to identify our A, our B, and then our F from the PDE given. So here from this our A is the coefficient of ux, that is y. Our B is the coefficient of uy, that is what, s squared. And then our F is what, 0. So once we have this, we form the characteristic equation, which is giving us the x all over A is equal to dy all over B is equal to du all over what, f. So let's plug in this. So we have the x all over y is equal to dy all over what, x squared is equal to du all over 0. So as I said, when f is equal to 0, we only form one equation. But when f is not equal to 0, we form two equations from the characteristic equation. But since our f is equal to 0, we are going to form only one equation, which is this. So I think this one will go away. So we'll be left with dx all over y. So once we read this welcome, what we do is we separate the variables if possible. So you can see that we have the x and then s squared, we have the y and then y. We can separate the variables into the x and then the y by cross multiplying, right? You can see that this will multiply this and then this will multiply that. So we'll be left with what? S squared dx is equal to what? Y dy. Now once we read this little point, the fourth step says that we integrate both sides. So what do? We integrate. So we have the integral of that and then we have the integral of that. Now when we integrate s squared dx, we are going to get what? We are going to get s cubed all over what, 3. Then we add the constant of integration, that is what, c. And then when we integrate y with respect to y, we get what, y squared all over 2. And then we add the constant of integration. Since we have a constant and a constant minus a constant will still give you a constant. Example, you have 4 minus 3, we are getting 1. 1 is a constant, 4 is a constant, 3 is a constant. Since we are generalizing all constants to be c, we are just going to write only one constant. So let's claim this part. So let's make the constant the subject by sending this to the right hand side. So we'll be left with our c is equal to y squared all over 2 minus what? S cubed all over 3. Let's continue from this side. So from here we have our c is equal to y squared minus what, over 2 minus s cubed all over 3. Now let's do away with the denominators, okay, by multiplying through by 6. So we're going to have 6c is equal to what? 3y squared minus what? 2x cubed. Now when you have a constant times a constant, will still give you what? A constant. So let's take it as 6 times the constant c also give us a constant. 6 times, let's say the constant is 4. 6 times 4 give us 24. This is a constant. So a constant times a constant will give you a constant. And since we are generally all of them to be a constant, we can write it as c is equal to what? 3y squared minus 2s cubed. Now, when we look at the PD that was given, you can see that it is homogeneous. So the PD is y ux plus s squared uy is equal to 0. This is what? A first order linear homogeneous PDE. And the solution to this is what? The general solution to this is what? A function of what? The constant. So these are constants. It is given as this. So these are constant. And the general solution is given in this well form. So the general solution will be given as u of xy is equal to a function of this. So we have 3y squared minus what? 2s cubed. So this becomes our general solution. So this is what? Our general solution. And then we are done. But remember that we were given what? An initial condition. So these are initial conditions. So we have to continue to find what the particular solution, because the question says find the particular solution. So let's continue. So we have the initial condition u of 0y is equal to y squared. So let's continue from here. So we have u of 0y is equal to what? Y squared. Now this means that wherever we see x in the general solution, we should plug in 0. And wherever we see y in the general solution, we plug in y. So you can see that our x is equal to 0, and then our y is also equal to y. So the general solution, we had u of what? Xy is equal to a function of what? 3y squared minus 2s cubed. So we are saying that our x is 0, so here will become u 0, and then this will still be y is equal to a function. Now wherever we see x is 0, so 2 times 0 gives us 0, so we'll be left with what? 3y squared. Good. Now we have this. The initial condition is this, and then after plugging in the initial condition, we have this. So let's write it beneath. So we have, so as I said in my previous videos, I said that when you have two equations, let's say p is equal to 0 and q is also equal to 0, then we can say that p is equal to q. I believe you agree with me. Since this is equal to that, we can say that this is also equal to that. So we can equate them and write them as f of 3y squared is equal to y squared. So from here, we want to see what happened to 3y squared. That gives us what? Y squared. So what we are going to do here is to let any variable at all to represent what is in the function. So we have let p is equal to what is in the function. That is what? 3y squared. Then from here we make, since we have y squared here, we can start to make y squared a subject. So we have y squared will be given as what? P all over 3. So it means that wherever we see 3y squared, we can plug in what? P. And wherever we see y squared, we can plug in what? P over 3. So let's continue from there. So we have f of p is equal to, now we said that y squared is also equal to p over 3. So we have p all over 3. Now once you read this particular point, f of p is equal to p over 3, I mean this point, you go back to the general solution. Where is the general solution? So you come to the general solution, and then you pick what is in the function here to replace p. Let me repeat it again. When you reach here, you go back to the general solution, and then you pick what is in the function or the general solution to replace what? P. So if that happens, then we are going to have f of 3y squared minus what? 2s cubed is equal to, now p is still the same thing, so we have 3y squared minus 2s cubed all over what? 3. And therefore, the particular solution to the PDE with that initial condition given is what this. So let's rewrite it well. So we have our particular solution is given as u of xy is equal to what? 3y squared minus what? 2s cubed all over what? 3. And this becomes what? The particular solution. So we have the particular solution. Very, very easy and then simple. Let's look at another example. So we want to solve this particular equation, yux plus xuy is equal to u, using what? The characteristics equation. So the first thing that we are going to do is to write this equation in a standard form. And as you can see, it is already in a standard form, so we are going to go. And then the next thing is, or the next step is to form the characteristics equation. And before we can form the characteristics equation, we have to first find our a, our b, and then our f, form the equation given. So from there, our a is equal to the coefficient of ux, that is what? Y. And then our b is what? The coefficient of uy, which is what? X. And then our f is the function on the right hand side of the equal sign, that is what? U. Now once we have this, we can form the characteristics equation, which is giving us dx all over a is equal to dy all over b is equal to du all over f. So let's plug in this. We are going to have dx all over what? Y is equal to dy all over x is equal to du all over what? U. Now let's move on to the third step. The third step says that we should form one equation if f is equal to 0. Now you can see that f is not equal to 0, so we have to form two equations from that. We are going to form two equations from the characteristics equation. And remind you that the characteristics equation, which is this, has converted this PDE into an ordinary differential equation, and therefore we can make use of any of the methods that we know in solving ODE to solve this, or we can use the simple our simple integrating techniques to solve it. So we are going to form two equations from this. So we have our first equation, and this first equation is going to give us our first solution. So we are going to pair any one of them. So let's pick this one. We are going to pick this and then that for the start, and then we solve it. So we have dx all over y is equal to dy all over what? X. So from this you can see that we can separate the variables into x and then y. So we have this will multiply this will multiply that. So we are going to have s dx is equal to what? Y dy. Now from this we can integrate, right, with respect to x and then with respect to y. So when we integrate, we have the integral of that and then the integral of that. So when we integrate x with respect to x, we are going to get what? S squared all over 2. Then we add the constants of integration. So we have, let's say, c. And then when we integrate y with respect to y, we are going to get y squared all over what? 2. Very, very easy. And then simple. Let's continue from the side. So from this, we can decide to make c the subject. So let's say our c is equal to y squared all over 2 minus what? S squared all over what? 2. Let's clear the denominators away by multiplying 2 by the 2 or the LCM 2. So we are going to have 2c is equal to y squared minus what? S squared. Now when you have The C is a constant. Okay, you know constant. So 2 times a constant, let's say 3, will still give us what? A constant 6. So 2 times C will still give us what? A constant. So a constant times a constant is what? A constant. So we are going to write this as what? A constant, because we are generalizing all of it to be a constant. Then we have y squared minus what? S squared. So we have our first solution, which is this one. We have our first solution, which is C is equal to y squared minus what? S squared. Since f here is not equal to 0, we are going to have two equations. We have our first equation. We are going to look at the second equation. So we have our second equation. So with the second equation, since we have paired this and that, then we have to pair this with any of them. So we can pair this with that, or we can pair this with that. So you see that when we pair du and then dx, we have du all over u is equal to dx all over y. You can see that it will be very difficult for us, so we can't separate the variable because we have one or more variables. So we can't pick the u and then the x. Now let's write the u and then the y. So we have the u all over u is equal to dy all over x. With this same with this one too, we can't separate the variable because we have one or more variables, and therefore it's very difficult for us to continue. So what we are going to do here is to go back to our JHS and then SHS level, and then we apply some basic algebra from there so that we can continue from here. So the algebra that we are going to apply there is this one. When we are at the JHS or SHS level, in algebra, we said that when you have, let's say, two fractions, let's say 3 over 6, and these two fractions are equal, right? If you have two fractions, 3 over 6 and then 1 over 2, if they are equal, then we can say that when we add the numerators 3 plus 1 and then we add the denominators 6 plus 2, this should be equal to any one of these. So it should be equal to what? 3 over 6, and it should be equal to what? 1 over 4, 1 over 2. Now let's check and see. 3 plus 4 give us 3 plus 1 will give us what? 4. And then 6 plus 2 give us 8 is equal to 3 over 6 is equal to 1 over 2. Let's break them down. This will give us 1 over 2. This will give us 1 over 2. This will give us what? 1 over 2. So you can see that they are equal. We can decide to also subtract them. So we have 3 minus 1 all over 6 minus 2. And this is equal to any one of the fractions. You see, it is the same as 3 over 6. And it is also the same as what? 1 over 2. Let's check it out. 3 minus 1 will give us 2. 6 minus 2 give us what? 4. We have 3 over 6. We have 1 over 2. Let's break that down. This will give us what? 1 over 2. This will give us 1 over 2. This will give us what? 1 over 2. So from this principle, we can generalize and say that if you have, let's say, A over B is equal to C over D, then it is the same as adding A to C and then B to D, and this is going to give us, and this is also going to give us A over B and then what? C over D. With the same thing, we can subtract them, so we can say that A minus C all over B minus D is equal to what? Any one of them, A over B is equal to what? C over D. So we are going to apply this principle in algebra to help us solve the second equation. I believe you are getting me. Okay. So we can see that dx plus dy, so we have dx plus dy all over what? Y plus x is equal to what? Du all over u, applying the concept that we have just learned from basic algebra. Now, at this point, what we are going to do is that we are going to go back to our ODE when we're looking at the integrating factor depending on y and then x. Depending on y on x, we came across certain equations. I think there were 8 or so, and one of them is that when you have dx plus dy all over y plus x, this is the same as the ln y plus x. So we are going to replace this in place of that. So we said that the x plus the y all over y plus x is equal to the ln of what y plus x. So in place of this equation, in place of this, we are going to replace what? The ln. Very interesting. If you have forgotten, please go back and then check those equations that I'm talking about. So we are going to have this to be what? The ln of y plus x is equal to what? Du all over u. Now once we read this, we integrate both sides. We do what? We integrate. So we have the integral of that, and then we have the integral of that. So when we integrate the ln y plus x, we are going to have what? Ln y plus what? X. Now let's add our constant of integration. So we have c. This one is c1. Let's make this one c1, and then let's call this c2, since we are having two constants. And then when we integrate the u with respect to u, we can write this as the integral of 1 over u du. So you can see that this is a function and a derivative. So when you integrate, we are going to get the length of that function. So we are going to have ln u. So let's make c2 the subject, so we can send the whole of this to the right hand side. So we have our c2 is equal to ln u minus what? Ln y plus what? X. Very easy and then simple. Let's continue from this side. So we have our c2 is equal to, applying our basic knowledge in logarithm, as I said earlier on, we pick one of the log and then we divide their argument y plus x. So we have one of our solutions too. So this is one of our solutions. Good. So we have one solution, another solution. So you can see that we have two solutions, C2 and then C1. And whenever you have two solutions, what do is that we merge them into a single solution. So when you have this is what we are going to do. One becomes a function of the other. So it is either that C2, we have C2 becomes a function of what? C1, or C1 becomes a function of what? C2. Any one of these is going to give you the same answer. So let's take C2 to be a function of what? C1. So we are picking this C2 to be a function of C1. So C2 we had ln u all over y plus x is equal to a function of C1. C1 we had y squared minus what? X squared. Now let's make u the subject from this equation by what? Taking u on both sides of the equation, so that this u will cancel what? The ln. You'll be left with what? U all over y plus what? X is equal to u exponent, a function of what? Y squared minus what? X squared. Now we want to make u the subject, so we can multiply this by what? Y plus x. So we have our u is equal to y plus x multiplying u exponent fy squared minus what? X squared. So we can say that the general solution for this equation given is what? U at x, y is equal to y plus x multiplying u exponent, a function of y squared minus what? X squared. Very easy and then simple. So this is our general solution. Since we were not given any initial condition, or zero condition, our general solution becomes this. So let's look at this particular question. We want to solve the equation ux plus x plus y uy is equal to 0. And we are being given the initial condition u0y is equal to u exponent negative y. We want to solve this equation. So what we are going to do is to identify our a. So we have our a is equal to what? The coefficient of us, that is 1. And then we identify our b. Our b is the coefficient of uy. We have x plus y. So we have x plus y. And then we identify our f, and that is what? 0. So once we have this, we write the characteristic equation for this. You know that the characteristic equation is given as dx over a is equal to dy all over b is equal to what? Du all over what? F. Now, once we have this, we are just going to plug in this. So we have dx all over a. Our a is what? 1. Then we have dy all over b. Our b is what? X plus what? Y. And then we have du all over what? 0. Whenever your f is equal to 0, we only have one equation being formed. And when f is not equal to 0, we are going to have two equations being formed. You can see that f is 0, so it means that this one will go, you'll be left with what? This zero part. So we are going to make use of this zero part to find our solution. So we are going to have dx is equal to dy all over what? X plus y. Very, very easy and then simple. Now dx over y is the same as dx. Now this zero point, you can see that, let's bring the 1. So at this zero point, we are just going to do our cross multiplication. This will multiply this, this will multiply that. Remember that we can't separate the variables because of this x plus y. We can't separate the variables, so we have to go for another option. So we are going to have x plus y multiplying what? Dx is equal to what? Dy. Now let's divide both sides by dx. So we have dividing both sides by dx, both sides by what? Dx. So we have our x plus y is equal to what? Dy all over what? Dx. Very, very easy and then simple. Now let's continue from here. So we have dy all over dx is equal to what? X plus y. Now let's bring y to the left hand side of the equation to have dy all over dx minus y is equal to x. Now, have you seen this kind of equation before? Remember that this is what? An ordinary differential equation, because the characteristic equation has converted this PDE to an ordinary differential equation. So this is what? An ordinary differential equation. Have you seen it somewhere before? So this PDE is of this well form: dy dx plus p of x y is equal to what? Q at x. So whenever we have an ordinary differential equation of this well form, we make use of what? The integrating factor. We make use of what? The integrating factor. Integrating factor. Because this ordinary differential equation looks like this particular one, so therefore we can make use of what? The integrating factor. So when we are making use of the integrating factor, we are first going to find our p of x from the equation, and then we find our q at x. So we have our p at x is what? The coefficient of what? Y, which is what? This, and that's what? -1. And then our q at x is equal to what? This. So that is that. So this map to that, this map to that, and then this also map to that. And then our q at x is what? X. So our integrating factor, which is given as this, is e integral of p at x dx. So we have our e integral of p at x, we have -1, and then we have dx. So we are going to have e. When we integrate dx, we are getting what? X. So we have minus x. Therefore, our integrating factor is given as e exponent -x. Now, once you have this, we write the general solution for the ordinary differential equation using the integrating factor, and that is given as y is equal to the integral of q at x multiplying the integrating factor we have dx plus the constant c all over the integrating factor. Very, very easy and then simple. So let's continue from here. So we have our y is equal to the integral of our q at x is what? Q at x is x. So we have x multiplying the integrating factor we had. So this is our integrating factor. We had e exponent what? Negative x. So we have e negative x, and then we have dx plus the constant c all over the integrating factor e exponent negative x. Now let's integrate x multiplying e exponent negative x dx. Now we can integrate this using the integration by parts. So we have u and then v prime. Our u, we are going to have x, and then our v prime, we are going to have e exponent negative x. So we are going to differentiate x till we get 0. So we have 1 and then 0. Then we are going to integrate e exponent negative x as many times we differentiated what? X. So when we integrate e exponent negative x, we are going to get what? Negative e exponent x. When we integrate again, we are going to get e exponent what? Negative x. Now once we have this, we have downward cross product. So this is going to take that, and then this is going to take that. Then after that, we add our plus minus. So we are going to have x minus x e exponent negative x, and then this one is also going to give us minus e exponent what? X. So it means that when we integrate x multiply e exponent negative x, we are going to have this. So this is what we are going to have. So let's continue from there. We are going to have negative x e exponent negative x minus e exponent negative x plus this constant all over e exponent negative x. So we have our general solution to be. Now we can write this as negative x e exponent negative x minus e exponent negative x all over e exponent negative x plus c all over e exponent negative x. We are just splitting it into 2. Now we can factorize e exponent negative x out. So we have y is equal to e exponent negative x. We are left with what? Negative x, and then we have minus 1. Then we have plus. We can write this in an index form as c e exponent what? X indices. And then we have this is over e exponent negative x. So from here we can see that this will cancel this. So we are left with y is equal to minus x minus 1 plus c e exponent what? X. Let's make c the subject. Okay, so we can start to bring all of this to the left hand side, so that we will have y plus what? X plus 1 is equal to c e exponent what? X. We want to make what? C the subject. So let's divide both sides by e exponent x, e exponent x, so that e exponent x will cancel e exponent x. We are left with what? So we are left with c is equal to what? C is equal to y plus x plus 1 all over e exponent what? So you can see that with the PDE given, this PDE given, this PDE given, you can see that it is equal to 0. Then the general solution is going to be a function of the constant. It's going to be what? A function of what? The constant. So we have u of x comma y is going to be a function of what? The constant. So we have our u of xy is equal to a function of what? The constant is what? Y plus x plus 1 all over what? E exponent x. So this becomes our general solution. This becomes what? Our general solution. General solution. So this is our general solution. But remember that we are being given an initial condition. U of 0y is equal to e exponent negative y. So you have to find what? The particular solution. The particular solution. So we have the initial condition given. U of 0y is equal to what? E exponent negative y. So this means that wherever we see x in the general solution, we should plug in 0. And then wherever we see y in the general solution, we should plug in y. So when we do that, we are going to have x is 0, so we have u of 0y is equal to a function of, now when we plug x here, we are going to have y plus what? 1, because this is going to be 0. And then when we plug in 0 here, we have e exponent 0. That gives us what? 1. So we have all over what? 1. And we know that y plus 1 over 1 is the same as what? Y plus 1. So we have our u of 0y is equal to what? Is equal to a function of y plus 1. Now this whole point, we are going to go back to the initial condition given, which is what? U of 0y is equal to what? E exponent negative y. Since this is equal to that, we can therefore say that this is also equal to what? That. So we have a function of y plus 1 is equal to e exponent negative y. Let's continue from where? Let's continue from here. So from here, we are going to let any variable to represent what is in the function y plus what? Y. So we are going to let p be equal to what? Y plus 1. From here, we can decide to make y the subject, so that we will have p minus 1. So this means that wherever we see y plus 1, we can replace it with what? P. And then wherever we see y, we can replace it with p minus 1. Very, very easy. So we are going to have f of what? P, because we are saying y plus 1 is p. So we have f of p is equal to g exponent negative y. Y is what? P minus 1. So we have p minus 1. So you can just simplify it and write it as e exponent what? 1 minus what? P, because this will give us minus p, this will give us positive 1. So you can write it like that. Now this whole point, what we are going to do is that we are going to go back to the general solution and then write what is in the function to replace what? The p. We are going to go back to the general solution and then write what is in the function here to replace what? P. So we are going to have a function of what? Y plus x plus 1 all over e exponent x is equal to e exponent 1 minus p is what? This. So we have y plus x plus 1 all over e exponent what? X. Therefore, the particular solution for this PDE with the initial condition given is that, so we can rewrite it nicely as u at x at y is equal to e exponent 1 minus what? Y plus x plus 1 all over e exponent x. And this becomes what? The particular solution for the PDE, the particular solution. Very, very easy and then simple. Let's bring some brackets here to make it very nice. So this becomes the particular solution. Very, very easy and then simple. This brings us to the end of today's lesson. See you tomorrow. Bye bye.